Okay, in this video, we're going to talk about how to find the derivative of natural logs. And it's really simple. There's a formula and it looks like this. The natural log of f of x. And that means that I have the natural log of something with a variable. So there can be more than just x going on. And this is just telling you to take the derivative. So the formula for that is the derivative of the inside, which is this f of x part here, divided by the original f of x that you see here. Notice that the natural log is not in our answer. So when you're trying to memorize derivatives and derivative rules, it's always a good idea to kind of think of it in terms of something you can say in your head. Some of you see this and that's fine, but this is really the derivative of the inside divided by the inside. And if you think about it like that, then you don't have to worry about the notation and memorizing the form, as well as I say this to yourself a few times and you have it memorized. So here's an example. I want to take the derivative of this. So the derivative of y is just dy dx. And remember, I'm going to take the derivative of the inside. So we have to know our power rule here. So that's going to be 5 times 3, which is 15x. And I'm going to subtract a power from that, which is going to give me 4. I'm going to subtract 1. Divided by exactly what you see here on the inside, which is 3x to the 5th. Now that is my derivative, but we can simplify that further, and you should, to make it a little cleaner in case you have to work with it for something. 15 divided by 3 is 5, and x to the 4th over x to the 5th is just x on the bottom. So this would be my answer, 5 divided by x. Okay, let's look at another example. The derivative of y, again, we're going to write dy dx, or you could write y prime. And here we have this negative 5 here on the outside, and that's negative 5 times this, so that's just going to get multiplied. And then when we take the derivative of the natural log of x to the 4th minus 2x, we're going to take the derivative of the inside, which is going to be 4x cubed minus 2 divided by everything that's on the inside exactly like you see it. So x to the 4th minus 2x. Now, there's not a lot of simplifying that can be done here because we have this subtraction in between each of these. You could multiply this negative 5 through the numerator if you wanted to, and that would look like this, negative 20x cubed plus 10 over x to the 4th minus 2x. And that's pretty much all we can do as far as simplifying. You could take out a greatest common factor on the top and the bottom, but it wouldn't really, you wouldn't be able to simplify any further. So this is good. Okay, let's look at 2 more examples. For these examples, you do have to know the derivatives of your trig functions. Here we have cosine and here we have sine squared. So if you do not yet know your derivatives of trig, you need to go back and watch that video because that's going to be important. When I take the derivative here, again, the 2 is just going to kind of hang out. It's going to get multiplied by the derivative of the natural log of cosine x. And then we're taking the derivative of the inside. So the derivative of cosine is negative sine of x. And we would be dividing that by what I see here, which is cosine. Now, again, that's my unsimplified form of my derivative. However, I can take this negative and this 2 and write it together because this is 2 times negative 1, so it's negative 2. And then you could leave it sine x over cosine, but we should know that sine x over cosine x is tangent x. So this is really the simplified form there, okay? Last one, derivative of this, again, the 5 is just going to hang out. Now, inside this I have sine squared x. So when I take the derivative of that, that is actually chain rule in itself. And again, there's a video on chain rule. So I'm just kind of showing you how we can put all of these derivative rules together. But if you need to go back and watch your trig video and your chain rule video, do that. The derivative of sine squared, and guys, you can look at sine squared like this. That's the same. It's just when we write it, we kind of write the 2 in here. So this is going to be the 2 comes out front. The inside is going to stay the same. This is chain rule. Subtract a power, which gives me 1, times the derivative of the inside, and the derivative of sine is cosine. And so this whole part here is actually the derivative of sine squared x. So you might want to watch that chain video rule, or the chain rule video. So I'm going to put the sine squared on the bottom. Remember, because it was the derivative of the inside, which is all of this, over the inside. Now, if we want to simplify this, 5 times 2 is 10. Sine x over sine squared x actually just leaves me with a sine x on the bottom because one of these will cancel with one of these. This one will cancel. And then I still have that cosine on the top. So again, that's all fine. But we should know that cosine over sine is actually cotangent of x. And so that would be a simplified form. Okay, hope that helped. Go back and check out the other videos. They're going to be really important because you can have a number of different rules within one problem. So you do need to know all of them. See you next time.